Okay, we're going to solve another example problem about a new shape. We're trying to get the first moment area, Q, about line AA. AA is in the middle of this I shape here. And we still need to get Q. And what we're worrying about, or what the main issue is, we only care about this middle shape right here, the shape below AA. It's symmetrical about AA, so we only care about this shape here. Now let's absorb this photo first. This is an eye shape. The top part up here of these eye shapes and the bottom part are referred to as a flange. The middle part in between the eye, the vertical part, is referred to as a web. And like I said earlier in the lecture, if it's particularly thin, it will fail due to shear stress. And so that's why we're concerned about these shapes. Let's look at the dimensions as well. These dimensions are all in inches. It's 10 inches tall. The thickness of the flange is 2 inches on both top and bottom. The width of the flange is 6 inches. The thickness of the web is 1.5 inches. What's not shown is the height from the top of the web to the bottom of the web. But we can calculate that because 10 inches minus 2 inches minus 2 inches is 6 inches. And so if we start solving this, the first thing we need to know, let's get my text box back in here. Okay, there we go. Text box is Q. The equation is Q is equal to AP times Y bar. Okay. Let me format this so that the shape doesn't go away. Position, now I want to do info to text, I think. Let me format this. So that is in front text. There we go. Now everything shouldn't go away and get formatted weird. Okay, so we want to do the equation AP times Y bar. Now the AP that we're concerned about is just this area. Let's break this area into its individual parts. So I want to calculate the area of just the little web, so a web. Again, just this little part right here, but it stops right there. Its thickness is 1.5 inches. Its height, if we said previously, from here to here is 6, then half of that is 3. So then its total is 4.5 inches. Squared. Okay. Then we could calculate the area of the flange, which is just this part here. Well, it is 2 inches thick and it is 6 inches wide, which is 12 inches squared. And then, therefore, let me make this text box bigger. AP is just the sum of these two guys, which is just 12 inches squared plus 4.5 inches squared, which is just equal to 16.5 inches squared. And that's what AP is. Now, to do Y bar. This Y bar isn't just this big Y bar here. We want to know the Y bar from AA down to the centroid of just this little shape. Let's see if we can draw a line here to represent what I'm talking about. It's from here to whatever the centroid is of this shape, which is approximately there. That's what the y bar we need is. To get that y bar, we need to do the overall y bar equation where we use the y squiggles of the individual shapes. And so to do that, let me make this guy way big. We need to get the y squiggles, so I'm going to call it ys. If we do it for just the web, which I'm talking about this piece right here, just this little piece right here, this guy is 3 inches tall. The distance from AA down to its centroid, let me draw a line for that guy so we can see. I'm trying to figure out what the distance, that's not what I wanted to do, from here to here is. That's what I'm solving right here. If it's 3 inches tall, then that would just be 3 inches divided by 2, which is just 1.5 inches. Next, I need to do y squiggle of just this little flange. This guy, which is the distance from AA down to here. If I know that the distance of the web right here, from here to here, is 3, so that gives me 3 inches, plus half of the thickness here, 2 inches, divided by 2, that's just 3 plus 1, which is just 4 inches. Cool. So then now I have my y squiggles of the web, y squiggle of the flange, the area of the web, and the area of the flange. Now I could put this into the y bar formula, and since I'm using Word now, I think that I could use this cool equation guy. That's not what I wanted to do. I want to fiddle with this equation here. I want to do, maybe we'll just work with where it's at. It won't let me move it. So I'm just gonna start typing. Maybe that'll be easiest. Y bar equal to this little fraction guy. Yeah, let's do the little fraction guy. Okay. Area of the web, 4.5 inches squared, times the y squiggle of the web, 1.5 inches, plus area of the flange, 12 inches squared, times the area of the y squiggle of the flange, which is 4 inches. As to why this decided to go here, I don't know. Yeah, there we go. So it's on the same line. 4.5 was multiplied by 1.5 inches. Okay, I see. And then that is divided by the total area, which was AP of 16.5 inches squared. All of that, I do that, gives me 3.31 inches. 4.5 inches times the 1.5 inches, I got the 4.5 from the area of the web, times the y squiggle of the web, 1.5, plus the area of the flange, 12 inches, times the y squiggle of the flange, is 4 inches, all divided by the total area, gives me 3.31 inches. Now I can figure out what Q is. Q is equal to AP, which we just solved, 16.5 inches squared, times the 3.31 inches. Gives me our final answer, Q of 54.75 and it's in units of inches squared times inches, which is inches to the third. And that's our answer for Q of this shape.